creating rules and using authentication. This nugget is really going to tie the bow on the package of creating your access policies. In a prior nugget, we went through all the policy elements and all the pieces, the building materials that you can use to start creating your access policy for the internet. In this nugget, we're going to take the next step. We're going to finish planning out the access policies and figure out what rules we need to create and how to provide access. And then we're going to get into the three major areas of the ISA server that allow access: the protocol rules, the site and content rules, and the bandwidth rules. Using these three rule sets, you will be able to control internet access however you desire. Finally, we're going to get into authentication. You might think, wow, that seems pretty basic. Well, actually it's not. It takes it to a whole new level of access control. See, up till now, we've been talking about client access sets, defining IP address ranges for your clients. But let me ask you this. Would it be better for you if you could define access policies instead of on IP addresses, because who knows what IP address a computer has at any given day? Instead of doing that, why not define it based on usernames or even group membership? We can say the sales group in our Active Directory has this type of access. We're going to get into how you can allow that kind of control and that kind of permissions inside of the ISA server. The first thing we need to do is walk through how the ISA server processes incoming requests. Imagine this request is just an access attempt to yahoo.com or whatever website you fill in there. What it's going to do is take through this flow chart, and I've got my little color scheme where the blue arrows is no and the red arrows are yes. And we're going to walk through this together because the logic ISA server uses is a little different than the standard Windows 2000 logic. I mean, when you think of permissions in Windows 2000, what do you think of? Well, full control for everyone by default, right? And then you lock it down from there. Well, with ISA server, it's exactly the opposite. Watch this. We get a request coming in for yahoo.com. The first thing it's going to say is, does a protocol rule explicitly deny the request? Because if the answer is yes, we fall off the edge of the screen. And by the way, my edge of the screen is like the land of denial. As soon as we go off the right edge of the screen, we're denied. So if there is an explicit deny, obviously we are denied. But if it's not explicitly denied, look at this next one. Does a protocol rule allow the request? So if it does not allow the request, explicitly allow, we're falling off the edge of the screen. We're denied. So we need to have some sort of allow statement in there because, get this, by default, ISA's server will block anything that you do not explicitly allow. Now, if there is a protocol rule that does explicitly allow the request, it's going to go next to the site and content rule, and the same logic applies. If it's explicitly denied, then we're falling off the edge of the screen. If it's allowed, then we'll go on. But if it's not allowed explicitly, look at this. If a site and content rule does not allow the request, then we're denied as well. So again, we need to have rules allowing the traffic to go through before it will be passed through. Finally, we come to the last access spot, and that is packet filters. Packet filters are kind of a lower layer, where we're getting down to the port and IP address level, a lower layer filter that we can use as kind of a last-ditch effort to allow or deny traffic. And the last question it asks is, does a packet filter block this request? If yes, it will be blocked. If not, then we will retrieve the object. Now notice that the packet filter does not have to have an explicit allow. That's just because it's kind of like the lowest level, the bottom, final attempt to block requests. So a little different logic than what Microsoft usually uses in their access control, but that's good because with internet access, you can't be too safe. Keeping the method that ISA server uses to process requests in mind, you now can plan your policy strategy. There are two different ways to plan the strategy, the way I see it, two major umbrellas, I guess you could say. I call them fishnet and iron wall. This is just terms I've come up with. Don't go to your friends and say, oh, are you using fishnet security? Because they'll probably look at you funny. Fishnet, in my opinion, is trying to catch the big fishes. I mean, when you think of a fishnet, you've got the net and you've got pretty much that grid going across, and you know all the little plankton that swim around. They'll pass through the big holes. But, you know, the big fish, the fish that you're trying to catch is going to stick inside of there, and you eat it for dinner. FishNet security for ISA server catches the big guys. Maybe you want to block Kazaa traffic. So you allow everything through except Kazaa. Kazaa is your fish that you catch inside of that net there. The iron wall security, on the other hand, is, I mean, if you think about an iron wall, it's big, solid block. It'll block everything except maybe what you grab your little drill bit and allow through. Like maybe you allow a little hole through your wall that allows certain web traffic, maybe web traffic going to this one site going through, or maybe a hole through the wall just to allow SQL traffic to go through. So pretty much an iron wall security denies everything except what you poke the holes through to allow. So those are the two major strategies, in my opinion, that you can follow. Now by default, ISA server has that iron wall strategy because you have that unless you explicitly allow something, it will be denied. Now you can change that by just throwing an allow all rule in there and then putting some other rules before it saying this is what I want to deny to catch the big fishes. That's the idea of your policy strategy. The next step in the planning and implementing phase is going to be to implement your policy. Now that you have it planned out and you've either identified the big fish that you want to catch or you've identified the holes you need to poke, now you can create the rules on your ISA server. And as I mentioned in a prior nugget on policy elements, you then need to test it. Make sure you test, you try and access using the big fish style of traffic. And make sure it catches it. Make sure that it only allows the certain holes through that wall. The only way you're going to be able to evaluate it is to test it. That's a key when you set up your ISA server. Well, without further ado, let's get into the configuration. I'm going to bring up the ISA Management Console. I'm going to walk through the configuration of every single major rule that we have. I'm going to expand my ISA server under the servers and arrays. And you remember from a prior nugget that we had the policy elements that we configured, the different schedules, the bandwidth priority, destination sets, client address sets, all these different pieces. And these are essential to creating the rules. You need to have your policy elements created before the rules can be created because they use those elements. So I'm going to expand access policy, and there's our two major rules, protocol rules and site and content rules. Notice that bandwidth rules are kept separate because they're not really part of the access policy. They allocate bandwidth. I'm going to expand protocol rules, and you see none are created right now. So I'm going to right click on them, hit new rule. Now protocol rules, as the name implies, allows and denies certain protocols. So let's go ahead and name this, we'll say allow HTTP as my rule name. I click on next, and it says the first question, the response to client requests to use the protocol will be allowed or denied by this rule. Very important choice right here because it dictates what the entire rule will do. In this case, well, I know that ISA server denies everything except what I allow, so I'm going to choose allow in this case. I click allow and it says, what do you want to apply this rule to? This is where that strategy comes in. Is it a fishnet or is it a iron wall security? I click the down arrow and I have selected protocols or all IP traffic except selected. Well, watch this. I'll hit selected protocols and it appears below and says, what protocol are you speaking of? Well, remember, from our policy elements, we have the protocol definitions. All the protocols that I have in my protocol definitions are going to appear in this list of protocols. I'll scroll down and choose HTTP. That's the traffic that I want to allow. Well, we might as well allow HTTPS as well because that allows the secure HTTP traffic to go through. So HTTP and HTTPS, I'll kind of limit that down by only showing the selected protocols. And that is going to be what I allow through. Now we could have also done it by saying all IP traffic except the selected. See how the mentality kind of changes? In that case, if I selected this, everything except HTTP and HTTPS would be allowed. And of course, all IP traffic selects all IP traffic. But I'm going to keep it on selected protocols and hit next. See where all these policy elements are starting to come together? It says, during what schedule do you want to allow that protocol? I'm going to say during the work hours. So from, if we remember back, 9 to 5, I'm going to allow HTTP and HTTPS. It says, do you want to allow this for everybody, meaning any requests, specific computers, or specific users and groups? Now, if I choose specific computers, that's where it's going to my client address sets. And I get to say, well, I only want to allow the marketing people to use the HTTP traffic, or only want to allow marketing and salespeople to use that. And these client sets are sets of IP addresses, ranges of IPs. I could also go in there and allow specific users and groups where I need to actually add certain groups and certain users to allow the access. Now, to get into the user and group level, we have to have authentication. We'll talk about that later on in this nugget. I'll hit back and I'll just apply this to any request. Hit next, and comes up and says that's all you have. Hit finish, and right there I have defined my first protocol rule that allows access for anybody accessing through the entire array of servers that I have created. Now, if you really want to get granular and dictate exactly what people can access, that's where you can pull out the site and content rules. The site and content rules restrict what sites and what content people can access on the internet. Sounds basic at the beginning, but wait till you see how flexible they are. Before we get into the creation of the rules, I want you to notice that there is an allow rule that Microsoft's put in there by default. Notice it says allow any request on any schedule to all destinations and all content. Now you might be thinking, wait a sec, Jer, didn't you tell me that ISA server denies everything by default? Well, yeah, it does, but the reason why is there is no protocol rules created by default. And if there is no protocol rules, then everything is denied. The reason Microsoft put this rule in here was to make it easy for you to allow internet access. All you need to do is create a protocol rule dictating what protocols you want to allow to access the internet, and you're good to go. There's no site and content rules that will deny you. That's why they put this one in here. But this, in my opinion, is kind of the fishnet style of security. If you want to allow everything and then start denying from there, then you're just trying to catch the big fish. If you want to use that iron wall security and just allow certain items through and deny everything else, I'd recommend right-clicking on this and hitting disable. Notice you don't have to delete it. You can just disable it to allow it to not take effect until you enable that rule. So that's your way to get around that rule. Let's create a new one. I'm going to hit right-click, hit New Rule, and it comes up and says, welcome to the new Site and Content Rule Wizard. Let's name it just Example, because there's so much you can do with this. I just want you to see how flexible it is. First things first is it going to allow or deny client requests? Now, this is the biggest decision you'll make for the entire rule. It dictates what the rule does. And notice that if you deny, and it's an HTTP request, you can redirect them to a certain website. Get this. You could have an intranet server that maybe had your corporate policies, your intranet access policies on a web page, and maybe it was just intranet server /policy.htm. That could be a web page that you created that dictates all the policies. So when somebody's denied, it pops up and says, you're denied, here's our access policy, and browse through this to find out what you violated. Or you could get crazy and put something scary on that web page, whatever you want. If you do not check this box, it will just come up with like error 400 denied, and that's all they'll see. So it's a pretty good idea to check this so you can get a little more professional page that people will see when they're denied access. I'll continue down this trail. You see that it says, do you want to deny based on destination, deny access at certain times, or deny selected clients access to all external sites? These three are kind of broad things that Microsoft said, these are the common things that you would deny. Deny certain destinations, certain times, certain access. But overall, if you want to see all your options, go ahead and choose custom. These three are kind of the broad scopes. This lets you define whatever you want to define. I'll click on next, and it says, what do you want to apply this rule to? Do you want all destinations, all internal, all external, a certain destination set, and again that goes back to the policy elements that we created over here, and we defined certain destination sets, and before you might remember we set up a CBT nugget policy elements with the CBT nugget domains, or do you want to do all destinations except the selected set? For example, if we just wanted to allow access to the CBT nuggets domains, we would say I want to deny all destinations except this set. You see how this works? I'll click on next, and it says, now do you want to use a schedule? Do you want to always deny access to everything except CBT nuggets, or do you want to start assigning a schedule to it? Hit next, and it says, do you want to apply this rule to specific computers, specific users and groups, and this gets into the client address sets. Wow, do you see how detailed and flexible this is? That's what I mentioned at the beginning of this. It's opening a whole can of worms when you start creating these rules. That's why having a plan is essential. I'll say specific computers and add the marketing group. So the marketing people at this point during work hours can access only the CBT nuggets domain. Now we get into the content. Do you want to allow them to access CBT nuggets and any content type can come through, or do you want to allow just certain content types like audio, HTML documents, maybe images? Now you might think, where are these content types coming from? Well, these content types are coming from your content groups that you created under the policy elements. See, all these pieces are starting to fit together into creating the puzzle. We hit next, and now we have created our first rule, site and content rule, that denies access to everything except the CBT nuggets domains. And you can see as of right now, this is the only one in effect because we disabled the allow rule that Microsoft had in there by default. So let's move on to the last type of rule that's out there, the bandwidth rule. Now, if you're looking at this IP packet filter and thinking, well, what about that? Don't worry, we'll be coming back to those IP packet filters when we get to the nuggets discussing the firewall capabilities of the ISA server. Bandwidth rules, on the other hand, in my opinion, are the most confusing rules out there. Just because they take a while to get used to it. The logic of how they work is just a little odd. So let me show you this on the whiteboard before we get into the rule creation. The concept of bandwidth rules is pretty straightforward. It allows you to carve up your internet connection and allocate the bandwidth to the appropriate places. For example, I have my internet pipe down here. This is my T1 line, about 1500 kilobits per second connection. And what I could do is I could say that, okay, I want to carve out and allocate 200 kilobits per second to HTTP. I want to carve out maybe 400 kilobits per second for FTP, and another 300 kilobits per second for SMTP, and so on and so forth as I carve out the different internet bandwidth slices. And you might be thinking, well, what's so complex about that? Well, that's not the complex part. It's how it works. See, the current version of ISA server doesn't allow us to say 200K goes to this and 300K goes to that. What it allows us to do is create those ratios that we started talking about when we talked about the bandwidth priority policy elements in one of the previous nuggets. So we have to figure out the ratios before we can get the bandwidth rules to work correctly. Here's the idea. First off, there's different ways that we can allocate the bandwidth. Network allocation means we go to some traffic type, like HTTP, or maybe even something as broad as TCP or UDP or whatever classification you'd like to use. We have user allocation, which could go to users or group. I want the managers to have 60% bandwidth priority over the 40% of the rest of the employees. Maybe you have those two groups and you allocate it out that way. Now, with the unused priorities, you might say, well, what if the managers aren't using their 60% of the bandwidth? Does that mean it just gets wasted? No, those will actually, if it's unused, it'll go to the other groups. So if someone's not using it, it will go away. However, if they do demand it, if they're not using it and then all of a sudden the traffic comes through and the managers need it, it will be pulled back from that employee group. So bandwidth is never wasted by doing this. It's just allocated dynamically. Unused priorities, I just mentioned that. The rule order is important. As we start creating the bandwidth rule, you'll see that it has a specific order. The way it works is a top-down processing. You might have, for instance, the managers listed first, and they get 60% or a 60% chunk of the bandwidth. And then it comes down to the employees that have the 40%. And then you come below and you have HTTP that has another 30. And you might be thinking, well, we just went above 100, didn't we? Well, remember, it doesn't allow you to do percentages. It's all ratios. What's going to happen is when the traffic comes in, it's going to process top down. It's going to say, is this manager traffic? If so, then I'll allocate it from this group. If not, then is it employee traffic? If not, is it HTTP traffic? And if not, it'll eventually come down here to the default rule. There's a default rule. You might have saw it when I first clicked on that bandwidth rule a moment ago. If not, I'll jump back there in just a moment. This default rule sits at the bottom and catches anything that does not have a specific bandwidth allocation. This ensures that no matter how low on the totem pole you are, you'll get some bandwidth. It may be a little tiny bit, but you'll at least get some. That's what that default rule is there for at the bottom. This will make a lot more sense with the ratios when we actually see the bandwidth rules created. Let's take a look at that now. Looking in the ISA Management Console, the thing that we see under bandwidth rules is this default rule. Remember I told you there's the default catch-all rule at the very bottom, so that if you don't classify any traffic, it applies with this one? Well, there's something that is nagging in the back of my mind. We forgot to change it in the Policy Elements chapter. Let's check it now. We have our default rule right here, and I notice that it's tied to the default bandwidth priority. Well, I wonder what that's set to. Let's come over here to the bandwidth priorities policy element. And what we see here is we have the high class, the medium class, and the low class of bandwidth priorities, all these that we created in one of the previous nuggets. And then I see my default. Now, holy smoke, look at that. The outbound bandwidth and inbound bandwidth priority for the default is 100. Well, that's greater than even my high bandwidth. I've got to reduce that down. Let's go to bandwidth and let's change that down to 10 for both directions. Now that looks a little better. We have high, medium, low, and then default for anything else that doesn't apply. Let's jump back to the bandwidth rule and start creating our bandwidth scheme. I'll right-click, hit New, Rule, and let's create the scheme I was just describing over on the whiteboard a moment ago. I'll create a rule for the managers. And this applies to all IP traffic coming from the managers. Scheduled, always. We'll say that this applies to a specific group. I'm going to click on Add, and beforehand I conveniently created a managers group, and I'm just selecting my object types as users and groups. I created a managers group that I can place into here. Here it is, right down at the bottom, and right there I've added managers to my object name. So click on OK, so it's applying to the managers group. Hit Next, says apply the rule to all destinations, so anywhere that the managers access. And then it says any content group. See, you can get specific with this as well. I can say I want managers to have the priority, but only when they access maybe streaming audio or streaming video links. But for now, I'll just say all content groups. I hit Next, and this is a key point right here. It says what bandwidth priority do you want to use? Well, I don't want to use the default. That's the 10 that we just adjusted. You see that down here. I want to change it over to the high bandwidth priority that we created in one of the previous nuggets in the bandwidth priority policy element. So I select it at 99. Click Next and Finish. Now, here's the key point. What does that mean? I mean, they got 99 bandwidth priority. Does that mean 99% of the bandwidth? No. You have to make sure you catch this right here. The way the bandwidth priorities work is a ratio. I have 10 as the default, 99 as the high, 33 as the low, and 66 as the medium. Here's how you figure it out. You might have noticed I've had the calculator open down here. It's because I can't do this in my head. What you do is you take all of your priorities. I mentioned it was a ratio. Take all of them and add them together. I'll put 10 plus 99 plus 33 plus 66. What's our grand total? 208. So now I'll take 99, which is my manager's priority, divide it by 208. What does that give me? 0.475961. That means they'll have about 47, 8-ish% of the overall bandwidth. That's how the ratios work. And that's the easiest way to figure out how much real priority the managers will end up getting. Let's create a couple more of those bandwidth rules. I'll right-click, hit New, Rule, and let's create one for the employees. And it says apply to all IP traffic. We'll do a similar thing. I'll select users and groups. And again, beforehand I went out and created an employees group. I'll just go ahead and type it in there and hit check name. There it is. Employees group. I've added it. Next, apply it to all the destinations, all content groups. And here's the key. I'm going to select. We'll say the employees have a medium bandwidth priority of 66. I hit next and then finish. Now notice all along we've been creating them, this order has been changing. The default rule will always be last. You can't change that. But this is how it's going to work. Let's say that I had an employee who was also a manager, and for whatever reason they were actually assigned to both groups in my Active Directory or in my local server user database. Well, what I want to do is I wanted to make sure that the managers are at the top, move up. So that way, if somebody is a manager and an employee in both groups, they will get the manager priority because that will apply first. That's why this order is important. Same thing, I'll go ahead and create another one, new rule for HTTP traffic, completing the scenario that we discussed on the whiteboard just a moment ago. The only change is I'm going to apply this to selected protocols, move down and choose my 2 HTTP protocols. Next, I'll just next through this and give HTTP, let's give them a low priority, but still that's higher than the default priority that's sitting there last. I'll hit next and finish. Now here's the concept. I want to make sure I move this down below because if a manager accesses HTTP, what's going to apply first? Well, right now this HTTP traffic is going to apply first, so the manager will end up getting the low priority when compared to the rest. So I'm going to move this down, move it down, past the managers, past the employees. So if somebody that isn't in the managers and employees group uses HTTP, then this rule will apply, and they'll at least get a little better priority than the default rule at the bottom. Does this bandwidth rule make sense to you? That's the whole idea. It's gonna take some time to soak in. The best way to do it is to draw it out on paper and really figure out how these priorities work with that ratio. Add all the numbers together and divide it out as a percentage. That's how you figure out how much real bandwidth these ratios will add up to. Now we just created bandwidth rules that allocated bandwidth to the managers and employees user groups on our ISA server computer. But how does the ISA server really know if somebody's a member of the managers or employee groups? Well, it does that through authentication, user authentication. And each client does authentication a little bit differently. Well, let's start with the Secure NAT client, because the biggest disadvantage that you have with this kind of clients is it does not do authentication at all. You cannot use user and group-based restrictions if you have Secure NAT clients. Secure NAT clients can be restricted based on the sites they go to, the content they access, the IP addresses of these computers, the protocols they're using, the time of day. Any one of those can restrict Secure NAT clients, but you can't do it based on user or group membership. Biggest disadvantage. Easiest client to configure, biggest disadvantage right there. Firewall clients, on the other hand, can have any type of restriction, including user or groups. However, the firewall client requires a client install. And what that means is that you have to have a Windows machine to install it on. Windows Millennium, 98, 2000, any one of those will work just fine. However, that you have to install a client on every single computer. Web proxy clients, on the other hand, is one that can use user authentication based on the web browser that you're using. If the web browser supports authentication, then you should be able to do that. Now here's a catch. Say you want the benefits of the easy config of Secure NAT and all the functionality that they provide. However, if you want authentication, you can combine the web proxy client with Secure NAT. Here's what that means. On the client, you'll configure all the IP, the subnet mask, and the gateway to point to the ISO server. That'll make it a secure NAT client. Then you'll go into the web browser on that computer, hopefully Internet Explorer because it works best with authentication with ISO server, and you'll configure that as a web proxy client. So Internet Explorer on top of that will combine these two client types. So that's a way to get around it without having to install the firewall client software. Now the type of authentication that these clients use is exactly the same as Internet Information Server. Let's look at that right now. If you are familiar with and have had experience with Internet Information Server, the web server that comes with Windows 2000 or 2003, then when you see these authentication methods, you probably go, oh yeah, that's the same thing. Internet Information Server supports the same ones. ISO Server supports any of these 4 authentication types for the clients authenticating their credentials to the ISO server. The first one is the most dangerous. Basic authentication. And I'll put my little danger symbol right here. The reason why is basic authentication is supported by just about any browser. I mean Linux, Macintosh, what's the name of that computer? Macintosh, Apple, Windows, anything can support basic authentication. The reason I have my danger symbol here is because it is clear text. That means usernames and passwords go across your network unencrypted, and anybody with a packet sniffer can grab that information. So highly advise against using that. Digest authentication allows you to create authentication in your domain where you actually have hashing occurring and some sort of encryption occurring between the ISO server and the computer. However, this one requires Internet Explorer 5.0 and later. Now 5.0 has been out for a while, so that shouldn't be too hard of a requirement to meet. Integrated Windows authentication actually pulls out that Kerberos protocol. Again, for those of you guys that have gotten deep into the Windows 2000 admin, Kerberos is one of the most secure authentication protocols out there. It's a challenge response style protocol that never actually sends the password across the network. You can get into some deep architecture of how that works, but if you can use this, this is usually the best way to go. The requirements is that you actually have this set up on a Windows network, again using Internet Explorer. This actually works with Internet Explorer 2.0 and later. Finally, the client certificate is where when you get into those X.509 certificate standards, and every single client in your network has a certificate, and most likely you have a certificate server set up to do that. Those certificates can be used to authenticate the client against the ISO server. So any one of these 4 options of authentication can be used to make sure that your users are who they say they are when they're trying to access web content. However, by default, the ISO server isn't set up for authentication. Let's do that right now. Authentication is enabled on a per server basis. So we do it from the server. I'm going to right click on the ISO server itself, hit Properties, and go to the Outgoing Web Request tabs. Under here we see what's called a listener. Listeners are just port numbers that are configured on the internal interfaces of the ISO server that it will respond to. Oh, by the way, if you ever want to change the port number that the ISO server listens on to something other than 8080, which is the port number you need to direct all your web proxy clients to, this is where you can do it. Now the magic checkbox is sitting right down here. Connection settings, as of right now, it will not ask unauthenticated users for identification. So I'm going to check that box. I'm going to say ask them and hit apply. Now it will pop up and it says, I do need to restart the web proxy service. Do you want to save it and then not restart the service, meaning you'll have to manually do it, or save it and restart it now? And I love the wording underneath this. It says the services will restart within some minutes. It's the mystery time. I have found that when you use this, it usually restarts within a few seconds, so don't worry about that. The problem with this is if you turn this on and people are actively using it, when the web proxy service starts, they'll lose their internet access for a few seconds while the service restarts. So go ahead and do that. Nope, let me go back in there. I also need to choose the authentication type. You see that unauthenticated users are being authenticated now. And if you look right here, let me scoot this over a little bit, the authentication method is set to integrated. That's the default. But if I want to change it, I select my listener, hit edit, and right here is all the 4 different options, or 5 different options. We have a server certificate as well. But the 4 major authentication options down here that we can use for our clients: the basic authentication, digest authentication, integrated authentication, most secure and default, and the client certificate authentication, where we actually have each client assign an individual certificate. So from here, we would be able to check and select any authentication methods that we want. And we can have multiple authentication types if that's what we'd like to do. The goal of this nugget was simple. It was to provide secure internet access for your corporation. And by now you should understand, using this nugget and the prior one on the policy elements, you should understand how to do that for your employees. Talk about planning the access policies, creating the protocol, site, and content rules, those rules that allow us to control what type of access they have, setting up the bandwidth rules that allow us to carve up our internet connection pipe and allocate bandwidth to certain applications. In my opinion, one of the most difficult rules to understand because of the ratio systems. You might want to remember that for Who Wants to Be a Millionaire. And then using authentication to make sure that we can authenticate our users to apply restrictions based on the users and the groups. I hope this has been informative for you, and I'd like to thank you for viewing.